Welcome to this activity, which is an application to economics after optimization. So we have a company which manufactures and sells X digital cameras per week. The weekly price, demand, and cost equations are respectively P equals 400 minus 0.4x and C of X equals 2000 plus 160x. The first question is, what price should the company charge for the cameras and how many cameras should be produced to maximize the weekly revenue? The second part is, what is the maximum revenue? So here, before starting, my recommendation is to find your domain for this problem, because here we didn't specify for which X we have this price demand equation, so we have to use the real life conditions, let's say, to find the domain of our price demand equation. We already know that X is greater than 0, so X is greater than 0 because X represents a quantity. So by setting this condition, we have the lower limit of our domain. Now, we know also that P is greater than 0 since it's a price, okay? To be consistent, let's put it strict, okay? Because we can't sell something for free, okay? Now, with this second condition, we're going to write that 400 minus 0.4 x greater than 0, which means that 400 greater than 0.4 x, which means that 1000 by dividing by 0.4, 1000 greater than x, or x is less than 1000, and here we have our upper limit. So the x must be in this interval, 0, 1000, open, okay? So we're gonna work on this interval, guys, okay? Now let's move to the first question, which is, what price should the company charge for the cameras and how many cameras should be produced to maximize the weekly revenue? So the question is about the maximum revenue. So first of all, let's write our revenue function, R of X, which is equals to X times P. So equals 400X minus 0.4 X squared. Now we compute our derivative, R prime of X, equals 400 minus 0.8 x. It's defined everywhere, so there is no point where R is defined and R prime is not defined. We just set this equals 0 and find x. So x will be equal to 400 over 0.8, which is 500 cameras. So this is the unique critical point, okay? Now, the question is, maximize the weekly revenue. Are you sure that you have a maximum here? Not yet. It says only that this is a critical point. So to check that it's a maximum, we're going to use the second derivative test. It means we're going to make the derivative of R, okay? So R second, which is equal to negative 0.8, since R of X is 400 minus 0.8x. So differentiate this function, you're going to find negative 0.8. It doesn't depend on X, so we don't need to compute it at X equals to 500. It's always negative. Since the second derivative is negative, we have a local maximum. Remember that at a critical point, you may have a maximum or a minimum. To check this, check the sign of f second, okay, the second derivative. If the second derivative is negative, therefore it's a maximum. If the second derivative is positive, you have a minimum. So here we have a maximum, since the second derivative is negative. Now, the question is, what price should the company charge for the cameras and how many cameras? We found the quantity, which is X. To find the price, just substitute X by 500 in the price demand equation. You're going to find that P equals $200. Okay? And what is the maximum revenue? You can either multiply 500 by 200, okay? You're going to find $100,000, or you compute R of 500, okay? So R of 500, which is equal to $100,000. So this is the maximum revenue, and we're going to answer to the question with a sentence. We're going to say that the maximum revenue is $100,000, okay, obtained by selling 500 cameras, at which price? At $200 each, okay? So here we answered to our question. Now let's move to the second question, which is use the second derivative test to find the maximum weekly profit. So the question is about profit, okay, and find the maximum weekly profit. So how much should the company charge for the cameras, and how many cameras should be produced to realize the maximum weekly profit? So first of all, we have to determine our profit function. So profit function equals revenue function minus cost function, which is given, okay? So here the revenue function, you obtained the revenue function in the previous question. It's 400x minus 0.4 x squared minus the cost function. Be careful about inverting the sign of the cost function since we have a negative sign, minus 2000 minus 160x. You can group the similar terms, so you will find negative 0.4 x squared plus 240 x minus 2000. So this is the profit function, okay? It's defined on 0, 1000, as the price demand equation is defined on 0, 1000. We compute p prime of x to find the critical points. So p prime of x equals negative 0.8 x plus 240, okay? Now set it to 0. It's defined everywhere, so we'll just set it to 0, and we'll find that x equals 240 over 0.8, which is 300 cameras. So this is the only critical point, okay? We check that it's a maximum by computing p second of x, second derivative test. We find that p second of x is negative 0.8. It's always negative. If it depends on x, you have to substitute your x by the corresponding critical point. But since here it's a constant, it's always negative, we know that it's a maximum, okay? So this point is a maximum. Of course, you compute the price, p, okay? Remember that p is equal to 400 minus 0.4 x. So if you substitute x by 300, you will find that p equals $280. And of course, you compute your maximum profit by computing p of 300. And here, the profit obtained by selling 300 cameras will be, if you substitute x by 300 in the p of x expression here, you will find that it's equal to $34,000. So to conclude, we're going to say that the maximum profit is obtained by selling $300 cameras, okay, at which price? At $280 each. So at $280 each, okay? That's it. Thank you for your attention, guys, and see you in the next videos.